Welcome friends. Now the next topic that we are going to see in the arc welding is the electrodes that are used in the arc welding. Okay. So if you talk about the electrode, so what is the basic function of electrode is that it acts as an element for completing the circuit. Okay, that is the first function. And if you talk about the second function, it will provide us the additional molten metal into the weld joint. So these are the two basic functions of the electrodes. Okay, now when we are having the two functions of the electrode to complete the circuit and to supply the additional molten metal into the weld pool. So suppose out of these two functions only one get satisfied, that is it is only completing the circuit but it is not providing any additional material. So that kind of electrode is known as the non-consumable electrode. Okay, so we are talking about the electrodes. So the first function is what? To act as an element. It is the element which is completing the circuit. And the second we talk that it will provide the additional or supply of molten metal into the weld pool. Okay, now out of these two only one gets satisfied, that is it is only completing the electric circuit but it is not supplying any additional material. Then it is known as the non-consumable electrode. Non-consumable, that is it is not going to get consumed, it is not going to supply the additional material into the weld. Okay, so these non-consumable electrodes basically should have some properties. That is, number one, it should have high melting point temperature, and secondly, very important, that is it should have high thermal conductivity. As it is not getting consumed, so it is heated. Okay, so it should cool time to time, so it should have the high thermal conductivity. Heat should not get generated into the electrode, it should conducted, it should flow away. Okay, so this is the main characteristic or property for the non-consumable electrode. So which are the non-consumable electrode that we are having? So very popularly we are having the tungsten, then we can also having the graphite or carbide as a non-consumable electrodes. But when we talk about the tungsten is suitable for both the polarities. You can have the direct current straight polarity, you can also use that tungsten for direct current reverse polarity, but remaining two are not like that. See, what are the non-consumable electrodes we are having? Tungsten, you are having graphite, and you are having carbon. Okay, so these are commonly used non-consumable electrode. Out of that, the tungsten can be used for AC or DC, but the graphite and carbon can only use for the direct current. Please remember this, tungsten can be used for AC or DC, but the graphite which are specially used for the direct current circuit in the welding. Okay, not suitable for alternating current. Okay, now if this is about the non-consumable electrode, now say your electrode is going to satisfy both these functions, that is it is going to complete the circuit as well as it is providing the additional molten metal supply to the weld pool. So this kind of electrode is known as the consumable electrode. Okay, so after non-consumable we are having the consumable electrode. Consumable electrodes. So here again you can, if you look at the consumable electrodes are getting divided into two types, that is the bare electrode or the coated electrode. Again the coated electrode can be classified into stabilizing electrode or shielding coating electrode or shielding electrode. Okay, so bare electrode is what? Suppose this is the electrode that we are having. This is electrode, so it is not having any additional coating of the fluxes on it. Okay, only it can supply the arc, as well as from the arc it will supply the molten material into the weld. So it is not giving us any additional characteristics, for say example for the arc stabilization, for the shielding of gases, etc. Okay, so bare electrode, it is not having any kind of coating. But if you look at the coated electrodes, so coated electrodes means there are the coating of the fluxes, some types of alloying material that really you want to add into the weld so that improve the mechanical properties. So these are the sources of coating for the electrode to get some additional things into the weld. So see here, whenever this coating is very thin, okay, whenever the very thin coatings are used, so only they can stabilize the arc, even not they can supply any shielding of the gases over the weld pool or weld bed. They are not again going to have any kind of slag generation. So only stabilizing purpose they are provided. So this coating is stabilizing coating, very thin layer coating on the electrode. Okay, now whenever we are having a thick layer of coating of the fluxes over the electrode, so basically they are providing the shielding around the weld zone so that the atmospheric contamination from the oxygen and nitrogen can be eliminated and you will get the good quality weld. So these kind of coated electrodes are categorized into the shielded electrodes or shielding coating electrode, and very little layer, thin layer of the coating on the electrode are classified as stabilizing electrodes. Okay, so what are the advantages that we are going to get by the provision of the flux coating onto the electrode? Of course we are talking about the coated type electrodes. So first thing, definitely we are going to get the deoxidization of the melt. That is very first advantage we are getting. Then if any harmful gases which are present around the weld zone, that can get absorbed, that is second thing. Third thing, we know fluxes are some portion of fluxes melt and they are react or combining with the impurities in the weld and floating over the weld pool and acts as a slag. This is nothing but the slag, which will again going to safeguard our weld from the atmospheric contamination. Also it can be sometimes acts as an insulator. So the fluxes or this coating is going to form a uniform layer or blanket over a weld pool, so that definitely your weld pool going to safeguard it from the atmospheric contamination. Okay, now these are the basic functions. In addition to that, what this coating is going to provide us as an advantage, definitely the arc stabilization. Okay, the arc is going to get stable arc we are going to get. We will discuss the what is mean by arc blow in next videos, but arc stabilization we can get from the coatings. Second important thing, that we can supply any additional alloying element to improve the mechanical properties of the weld, so such as say aluminum, copper, manganese, nickel, chromium, etc. These are the alloying elements we can supply from this coating into the weld pool or in your joint, so that you can get some good mechanical properties. So the next is what, very importantly, the supply of alloying element also we can do from this coating of on the electrodes. That is the second thing. Now, which are the coatings used in the coated electrodes? So we are having ferrosilica or ferromagnetic materials, we are having potassium compounds, we are having the titania based coatings, that is known as the rutile coating. Okay, so many times they are asking these coatings, so I will write here which kind of coatings we are using in the coated electrodes. I request students, please write down or try to note down what I am saying. So every sentence is not possible to write on the board, so listen carefully, or you can pause, have a pause, and you can note it down. Okay, now if you look at the coatings, which are the coatings actually used in the electrode? So we are having ferrosilica or ferromagnetic coatings. So these ferromagnetic coatings are basically, they are deoxidizing the melt. Then we can have the rutile, or this is the titania coating, TiO2, which is basically forming a slag over the weld pool and protecting your weld from the atmospheric contamination. Again, we are having these potassium compounds, we can use it for the stabilization of arc. You can write either S or Z, no issue. Stabilization of the arc. And also we can have the cellulose, high amount of cellulose, so that has the cellulose coatings. So what they are providing? They are providing the voluminous coating of slag, voluminous slag over a weld pool, so that the weld can be safeguarded from the atmospheric contaminations from the oxygen or from the nitrogen. But when you use this cellulose as a coating, the finish on the weld will be the coarser one. Okay, so only thing is that the finish on the weld is coarser, whereas when you are having the rutile coatings, you are having the finish on the weld as is fine. Okay, so these are certain coatings which are used in the coated electrodes. Understood? Now again, if you move further, then there is a specification of the electrodes, how they are specifying or how they are coding. So here I am going to take one of the example, and from that example we can have the coding of the electrode. Okay, so here now we are going to see the coding of heavy coated electrode for the standard steel according to Indian standards 8151974. Okay, so how these electrodes are coded? So here we are having, first of all, what are the basis of coding? the basis of coding is, what is the basis for coding? Number one, we are having the prefix, then we are having the code, and in some of the cases we are having the suffix to show some specific properties, okay. So generally this 6-digit code is very important, okay. So this is the basis for the coding, that is, initially we are having the prefix, then we are having this 6-digit code, again which is divided into two types, okay. Some first 3 digits are showing the performance of electrode or the application of electrode, and remaining 3 digits are showing the mechanical properties of the electrode, okay. So prefix, so here we are having prefix as E, that is solid extruded, and R, we can have this letter for the extruded with reinforcement, okay. Then after this prefix, see prefix में क्या use करते हैं, either E or R, E for solid extruded electrode or R for with, again reinforcement is there. Now after that we are having the code of 6 digit, which is again get divided into two parts. A will be indicating you first 3 digits, okay, that will give us the performance of electrode or application of electrode, okay. And next 3 digits, that is going to give us the mechanical properties, and after this code we are having suffix. So it is optional thing, actually this prefix and suffix are optional, so it is given for showing some specific properties, okay. So this is actually the basis for the coding of electrode, please understood. So for say example, I take like this E60411 okay, and here I write H. So these are the actual coding digits, and this is a suffix and this is the prefix. So this is the prefix and this is suffix, okay. So this is the extruded solid extruded electrode having the hydrogen content coating, hydrogen coated electrodes, okay. So like that we can have. So let us see the actual codes, what they are indicating. So the 6 digits, 1 2 3 4 6 digits. Out of first 3, what they will indicate? They will indicate the performance, and next 3 digit they will they will give us the mechanical properties, performance or the applications, okay. So let us see this first digit, what will indicate? The first digit indicate the type of coating, which type of coating you are having, ferrosilica coating, rutile coating, then you are having the oxide coating, okay, like that. The second digit is going to indicate the positions, the welding position, the welding position, the welding position. We are having flat welding is indicated as F, horizontal welding as H, vertical welding as V, and overhead welding as O, isn't it? So we are having the welding positions. Here we can have the type of coating from, there are numbers 0 to 9 and the welding positions. Then the third, it will give us the current conditions, the current conditions. Okay, so this is about first 3 digits which are shown or coded onto the electrode, which will give us the performance or application of the electrode. Okay, now we will see the last 3 digit. So here the 4th and 5th digit is going to indicate. Now see, the 4th and 5th digit here is giving us the range of tensile strength in the combination with the yield strength. Okay, so 4th and 5th digit is giving us, say suppose this is 1 is there. Okay, so 4th is 1 and 5th is 1. So it is indicating the strength in megapascal. So that is 110 megapascal. So here is 1, 2, then the strength will be 120 megapascal. Like that you will get the strength. Okay. Now here the 6th letter we are having as a suffix, or not 6th, this is the suffix letter. Okay. So suffix when we are using, when there is a specific property is there. So there are the letters H, J, K, L, P. So H is used for low hydrogen coating, The J is used for the iron powder coating, giving the recovery from 110% to 130% inclusively. Then we are having the suffix as K, that is same iron powder coating, giving the recovery from 130% to 150% inclusively. Then we are having L, that is again this iron powder coating, giving the recovery above 150%. Okay, so and this P is basically stand for the, this is for deep penetration coating, So just for information I am giving all these things. So you just remember that there is a prefix, then there is a 6-digit actual coding, and it is sometimes, not necessary, sometimes it is followed with the suffixes. Okay, so this is how we can code the electrodes. Understood? So for that I will take one example so that we can get how the codings are provided. Okay, so let us take an example of this electrode. This is electrode. Okay, so we know now the coding which is used in the electrode. So see, there is a prefix and there is a suffix is given and we are having this 6-digit code in between. So as I told you, we can have this E for the solid extrusion, P for deep penetration coating. Okay, now go with this 6-digit. So first digit is indicating what? The type of coating. Then see, for each digit from 0 to 9 there is having a detailed meaning, so you can have the reading for that. So which kind of coating, etc. So this is for, first thing is for coating, this 2 is for the position of the welding, 5 is for the current conditions, 4 and 5th togetherly indicating the strength in combination of the yield strength. Okay, that is 4-1, you should add 0 to that, that is 410 megapascal, and last digit is going to indicate the percentage of elongation during the tensile testing. So this is how we can code the electrode. Okay, thank you.